Introduction. Artificial intelligence is no longer a distant dream. It's transforming industries and reshaping the world faster than we ever imagined. Mark Zuckerberg's bold declaration that AI could replace programmers by 2025 has sent shockwaves through the tech community. The idea of AI acting as a mid-level engineer, writing, and improving code autonomously challenges everything we know about software development. Companies like Salesforce are already rethinking their hiring strategies, pointing to a future where traditional roles evolve or disappear entirely. But this isn't just a story about job loss. It's about innovation, creativity, and a technological leap that promises to redefine our potential. The rise of AI in software engineering. The rise of artificial intelligence in software engineering marks one of the most transformative moments in technological history. Over the past decade, advancements in AI have not only streamlined processes, but also expanded the horizons of what machines can achieve. From automating repetitive tasks to generating complex code, AI has begun to integrate itself as a fundamental tool for programmers. This shift is not a distant possibility, but an ongoing evolution that is reshaping the way the industry operates. Mark Zuckerberg's assertion that AI could act as a mid-level engineer by 2025 highlights the scale of this transformation. AI tools like GPT-4 and other generative models have already demonstrated their potential in assisting engineers with code completion, debugging, and optimization. Developers who once spent hours fixing syntax errors or implementing standard algorithms now find themselves relying on AI systems to handle these tasks within seconds. The ability of these tools to interpret vague instructions and translate them into functional code has begun to redefine the boundaries of what a programmer's role entails. The changes go beyond individual contributions. Companies such as Salesforce have started leveraging AI to improve productivity across their teams. Instead of hiring additional engineers, they are utilizing AI-driven systems to increase efficiency and reduce the need for human intervention in routine tasks. This paradigm shift is not merely about cost-cutting. It reflects a deeper rethinking of workforce structures and how technology can drive growth. AI's capacity to scale solutions without proportional increases in manpower enables organizations to achieve more with fewer resources, a concept that challenges the traditional employment landscape. The implications of these advancements extend to how software engineering itself is perceived. Historically, programming required years of specialized training, with engineers mastering languages and frameworks to create functional systems. Today, AI tools have begun to democratize this knowledge. Platforms now allow non-technical users to describe what they want in natural language, and AI translates those descriptions into working applications. This trend underscores an important shift where programming becomes less about technical expertise and more about conceptual clarity and problem solving. As AI becomes increasingly integrated into development processes, it's crucial to examine its role in augmenting human capabilities rather than merely replacing them. These systems excel at processing vast amounts of data, identifying patterns, and executing predefined tasks with precision. However, creativity, critical thinking, and innovative problem-solving remain areas where human engineers still hold a distinct edge. The collaboration between humans and AI has the potential to push the boundaries of what software can accomplish, blending the efficiency of machines with the ingenuity of human minds. Despite the excitement surrounding these advancements, there is an underlying tension in the industry. Students and early career professionals entering the field may feel a sense of uncertainty about their future. The prospect of AI taking over core aspects of software development can be intimidating, particularly for those who have invested time and effort into building their expertise. However, this evolution also creates opportunities for new roles and skill sets to emerge. Engineers who adapt to this changing landscape by mastering AI tools and focusing on areas like ethical AI development, data privacy, and user experience design are likely to find themselves in high demand. The rise of AI in software engineering is not without its challenges. Concerns about the ethical use of these technologies and their potential for misuse are growing. As AI systems become more autonomous, questions about accountability, transparency, and fairness come to the forefront. Ensuring that these tools align with human values and societal goals requires collaboration among engineers, policymakers, and ethicists. The industry must navigate these complexities carefully to harness the power of AI responsibly. AI's journey in software engineering also draws parallels with other industrial revolutions. In the past, automation in agriculture and manufacturing led to fears of widespread unemployment. Over time, however, these changes gave rise to new industries, roles, and opportunities. Similarly, the integration of AI into software engineering represents not just an endpoint, but a gateway to unexplored possibilities. By embracing this shift and exploring its potential, the industry can unlock new levels of creativity and innovation. The story of AI in software engineering is far from over. As it continues to evolve, its impact will extend beyond the tech world, influencing education, healthcare, entertainment, and countless other sectors. The ability to program no longer resides solely with those who understand the intricacies of coding. It is becoming a tool accessible to all. This democratization of technology holds the promise of empowering individuals and communities, enabling them to bring their ideas to life in ways that were previously unimaginable. The emergence of AI as a cornerstone in software engineering challenges the industry to rethink its priorities and embrace change. While there are valid concerns about job displacement and ethical dilemmas, the potential for growth, creativity, and collaboration outweighs the risks. By navigating this transition thoughtfully and responsibly, society stands to gain immensely from the transformative power of artificial intelligence. The path forward may be uncertain, but it is undoubtedly one of the most exciting journeys humanity has embarked upon. AI's role as a mid-level engineer. The concept of artificial intelligence functioning as a mid-level engineer represents a groundbreaking shift in how technology intersects with human creativity. Mark Zuckerberg's perspective that AI could fulfill this role by 2025 sheds light on the remarkable progress being made in the field of machine learning and its potential to reshape traditional engineering practices. This evolution is not simply about technology replacing human effort. It is about transforming the nature of the work itself and redefining the boundaries of what is possible within the industry. AI systems are already demonstrating capabilities that closely mimic the skills of an experienced engineer. Through advanced algorithms, these systems can write, debug, and optimize code with a level of precision that rivals human expertise. By analyzing vast amounts of data in real time, they can identify inefficiencies in existing code bases and propose solutions that streamline performance. This level of functionality reflects years of innovation, with AI now able to address tasks once considered too nuanced for machines. The efficiency of these systems lies not just in their ability to perform tasks faster, but in their adaptability to understand and learn from complex problems, often surpassing traditional methods of problem-solving. Zuckerberg's comparison of AI to a mid-level engineer resonates deeply with the industry because it implies more than just automation. It suggests a partnership where AI handles the intricate, repetitive aspects of coding, freeing human engineers to focus on broader, more creative challenges. For instance, in developing a mobile application, an AI system could take care of writing the foundational code, identifying errors, and ensuring compatibility across platforms. This process allows the human developer to invest time in crafting the user experience, improving accessibility, and conceptualizing innovative features that set the application apart in the market. One of the key advantages of AI as a mid-level engineer is its ability to operate without fatigue or error accumulation over time. Unlike human engineers, who may overlook minor issues during long coding sessions, AI maintains consistency, ensuring that tasks are completed to a high standard. This reliability is particularly valuable in high-stakes industries such as healthcare or finance, where errors can have far-reaching consequences. For example, AI has been utilized to develop secure financial software that adheres to strict regulatory guidelines, significantly reducing the risk of human error and improving overall system integrity. The development of AI with such capabilities also reflects the collaborative efforts of the tech community. Open-source platforms have played a pivotal role in accelerating progress, allowing developers worldwide to experiment with, refine, and improve AI models. This shared knowledge base has not only advanced the technology itself, but also made it more accessible to businesses and individuals. By leveraging these tools, startups and smaller organizations can compete with larger corporations, creating a more level playing field in the tech industry. Despite these benefits, the rise of AI as a mid-level engineer has not been without controversy. Concerns about job displacement and the long-term implications for the workforce are frequently raised. The ability of AI to perform tasks that once required years of training poses significant challenges for new entrants to the field, who may struggle to find opportunities to gain experience. This dynamic could lead to a scenario where the gap between highly skilled engineers and those just starting out widens, potentially limiting diversity and innovation in the industry. However, these challenges also present an opportunity to rethink how education and training are approached. As AI takes on more technical responsibilities, the skills required to succeed in software engineering may shift towards problem-solving, critical thinking, and creativity. Institutions could focus on teaching students how to collaborate with AI systems effectively, emphasizing the importance of adaptability and interdisciplinary knowledge. By preparing the next generation of engineers for a world where AI is an integral part of the workforce, the industry can ensure that it remains dynamic and inclusive. Another aspect of AI as a mid-level engineer is its potential to enhance team collaboration. In large projects, miscommunication and delays are often caused by the need for human engineers to interpret and implement complex instructions. AI systems can bridge these gaps by acting as intermediaries, translating ideas into functional code and providing immediate feedback. This capability not only improves efficiency, but also fosters a more seamless integration of diverse perspectives within a team. For example, in a project involving designers, developers, and product managers, AI could streamline communication by ensuring that everyone's input is accurately reflected in the final product. The ability of AI to interpret and act on natural language instructions is another transformative feature. This development has the potential to make programming accessible to a wider audience, allowing individuals without technical expertise to contribute meaningfully to software development. By enabling people to describe their ideas in plain language and have AI bring them to life, the technology opens the door to a new era of creativity and collaboration. This democratization of coding aligns with Zuckerberg's vision of a future where technology empowers individuals to achieve their goals without requiring specialized knowledge. While the capabilities of AI as a mid-level engineer are impressive, it is important to recognize the limitations of current technology. AI systems excel at handling well-defined problems, but often struggle with tasks that require intuition, ethical judgment, or a deep understanding of human context. These limitations underscore the importance of human oversight and the need for engineers to remain actively involved in the development process. By working alongside AI, engineers can ensure that the technology aligns with societal values and addresses real-world challenges effectively. The potential of AI to act as a mid-level engineer also raises important ethical questions. As these systems become more sophisticated, ensuring transparency and accountability becomes increasingly critical. Decisions made by AI can have significant consequences, and understanding how those decisions are reached is essential for building trust in the technology. The industry must prioritize the development of systems that are not only powerful but also fair, explainable, and aligned with human values. The journey of AI to becoming a mid-level engineer is a testament to the incredible progress being made in technology and innovation. By automating routine tasks, enhancing collaboration, and democratizing access to programming, AI is transforming the industry in ways that were once unimaginable. However, this transformation also brings with it a responsibility to navigate the challenges thoughtfully and ensure that the benefits of AI are shared equitably. As the industry continues to evolve, the role of AI as a partner in engineering rather than a replacement for human creativity will be critical in shaping a future that is both innovative and inclusive. The end of manual coding. The notion of coding without manually writing every line of code has been a dream for decades, and with advancements in artificial intelligence, this dream is rapidly becoming a reality. The idea that manual coding, as it has traditionally been practiced, might become obsolete represents a seismic shift in the software development industry. AI technologies are no longer just tools for supporting engineers. They are becoming central players, capable of transforming natural language instructions into functional applications with unprecedented speed and accuracy. The journey toward this shift began long before the emergence of today's AI models. Early programming required developers to write in machine code, laboriously detailing every instruction for the computer to execute. Over time, higher-level programming languages like C and Python simplified the process, but the act of manually typing out commands remained fundamental. Now, AI is challenging this paradigm by introducing systems that understand intent rather than syntax. Developers can describe what they want in plain language, and AI interprets these directives, bridging the gap between conceptual ideas and executable code. This change is not merely about convenience. It represents a profound reimagining of what programming is and who can participate in it. Traditionally, coding has been seen as a highly technical skill, requiring years of study and experience. AI, however, is breaking down these barriers. By allowing users to focus on the what rather than the how, it is enabling people from non-technical backgrounds to contribute to software development. This democratization of programming is empowering businesses and individuals to create tools that address their unique needs without relying on a specialized workforce. The implications of this shift extend far beyond the coding process itself. As AI takes on the heavy lifting of writing and debugging code, developers are free to concentrate on higher-level tasks such as system design, user experience, and long-term strategy. This newfound freedom allows engineers to channel their creativity into solving problems and envisioning new possibilities, rather than being bogged down by repetitive or tedious work. For example, instead of spending days building the back end of an application, a developer can focus on ensuring that the interface is intuitive and engaging for users. The impact of AI on manual coding is particularly evident in the rise of low-code and no-code platforms. These tools, which are already being widely adopted, allow users to drag and drop components to build applications with minimal or no coding required. Such platforms rely heavily on AI to handle the underlying complexity, ensuring that the applications are robust and scalable. Businesses are leveraging these platforms to rapidly prototype ideas, reducing the time it takes to bring products to market and fostering a culture of experimentation and innovation. Despite these advancements, the transition away from manual coding is not without its challenges. One significant concern is the potential for over-reliance on AI systems. While these tools are incredibly powerful, they are not infallible. Mistakes in AI-generated code can lead to vulnerabilities, inefficiencies, or unintended consequences. Ensuring that developers retain the skills necessary to review and refine AI outputs is essential for maintaining quality and security in software systems. The role of engineers may shift from creators to curators, overseeing the work of AI and ensuring that it meets the required standards. Another challenge lies in the ethical considerations of AI-driven development. As these systems become more autonomous, questions about accountability and responsibility become increasingly pressing. If an AI system generates flawed or harmful code, determining who is at fault, the developer, the company, or the AI itself, can be a complex issue. Establishing clear guidelines and frameworks for the ethical use of AI in software development is crucial for addressing these concerns and building trust in the technology. The potential for AI to eliminate manual coding also raises questions about the future of education and training in the field of software engineering. As the need for traditional coding skills diminishes, educational institutions must adapt their curricula to focus on the skills that will be most valuable in an AI-driven industry. Problem solving, critical thinking, and the ability to work collaboratively with AI systems are likely to become the cornerstones of software engineering education. This shift could make the field more accessible to a diverse range of students, as the barriers to entry are lowered and the emphasis on creativity and innovation increases. The broader societal impact of this transition is also worth considering. The ability to program has long been seen as a gateway to economic opportunity and career advancement. If AI removes the need for manual coding, it could fundamentally alter the dynamics of the job market. While some roles may disappear, others will undoubtedly emerge, focusing on areas such as AI training, ethical oversight, and user experience design. The challenge lies in ensuring that workers are equipped with the skills they need to thrive in this new landscape. For established developers, the decline of manual coding presents both an opportunity and a challenge. On one hand, the use of AI can significantly increase productivity and reduce the time spent on routine tasks. On the other hand, it requires a willingness to embrace change and learn new tools and methodologies. Engineers who can adapt to this new environment and integrate AI into their workflows are likely to find themselves at the forefront of the industry, driving innovation and setting new standards for what is possible. The evolution of software development from manual coding to AI-driven processes also reflects a broader trend in technology, the pursuit of simplicity. By abstracting away the complexity of programming, AI is making technology more accessible and intuitive. This trend mirrors developments in other fields, such as the transition from command-line interfaces to graphical user interfaces, which revolutionized the way people interact with computers. Just as GUIs made computing accessible to a wider audience, AI-driven coding has the potential to democratize software development, enabling more people to turn their ideas into reality. The integration of AI into software development is not the end of manual coding, but rather the beginning of a new era. Engineers will no longer be defined by their ability to write code, but by their capacity to innovate, adapt, and collaborate with AI systems. The focus will shift from the mechanics of coding to the art of problem solving, where creativity and human insight play a central role. This evolution represents an exciting opportunity to redefine what it means to be a software engineer and to explore the full potential of technology in shaping our world. As AI continues to advance, it is clear that the role of manual coding will diminish, but its legacy will endure. The foundational principles of programming will remain relevant, providing the framework for understanding and utilizing AI systems effectively. By building on this foundation and embracing the possibilities of AI-driven development, engineers and organizations can unlock new levels of innovation and productivity. Implications for the job market. The implications of artificial intelligence on the job market, particularly in software engineering, are profound and far-reaching. As AI systems continue to evolve, their ability to perform tasks traditionally handled by human engineers is fundamentally altering employment dynamics within the tech industry. This transformation is not limited to automation. It encompasses a deeper rethinking of roles, responsibilities, and the skills required to thrive in an increasingly AI-driven world. One of the most immediate impacts of AI is its ability to enhance productivity. Companies like Salesforce have already demonstrated how AI can reduce the need for hiring additional engineers by improving efficiency rather than increasing headcount. These organizations are leveraging AI to achieve more with fewer resources. This shift reflects a broader trend where businesses prioritize technological investments over expanding their workforce. For companies, this approach offers clear benefits: lower costs, faster project completion, and the ability to adapt quickly to changing demands. For employees, however, it introduces uncertainty, as traditional career pathways in software engineering may no longer guarantee the same opportunities as before. For those entering the industry, such as recent graduates or students considering a career in software development, these changes can be daunting. The idea that AI might replace certain aspects of their future jobs challenges the traditional narrative of what it means to be an engineer. Yet, While some roles may diminish or disappear, the evolution of AI is also creating new opportunities. The demand for professionals who can design, train, and manage AI systems is growing rapidly. These emerging roles require a combination of technical expertise, creativity, and ethical awareness, offering new pathways for those willing to adapt. The rise of AI also highlights the importance of reskilling and lifelong learning. As the job market evolves, engineers must continuously update their knowledge and embrace new tools to remain competitive. Those who can effectively collaborate with AI systems, leveraging their capabilities to solve complex problems, are likely to thrive in this new environment. For instance, understanding how to guide AI in generating code or how to evaluate its outputs for errors and biases will become essential skills. By focusing on these areas, engineers can position themselves as indispensable contributors to AI-driven teams. Beyond individual career trajectories, the integration of AI into the workforce has broader societal implications. The reduction in demand for certain roles raises concerns about economic inequality and access to opportunities. While large corporations may benefit from increased efficiency, the effects on smaller businesses and communities could be less favorable. Without the resources to invest in advanced AI systems, smaller firms may struggle to compete, potentially widening the gap between industry leaders and smaller players. Addressing these disparities will require thoughtful policies and initiatives to ensure that the benefits of AI are distributed equitably. The potential for AI to reshape the workforce is not limited to software engineering. Its influence extends to industries as diverse as healthcare, finance, manufacturing, and education. As AI takes on more responsibilities, the skills that define employability are shifting. Creativity, emotional intelligence, and the ability to work collaboratively with machines are becoming increasingly valuable. These qualities are not easily replicated by AI, making them critical differentiators for human workers. By fostering these skills, both individuals and organizations can navigate the transition to an AI-driven economy more effectively. While the disruption caused by AI can be unsettling, it also offers an opportunity to reimagine the nature of work. The automation of repetitive tasks frees up time and resources for more meaningful and creative pursuits. In the context of software engineering, this means that engineers can focus on innovation, user experience, and solving complex challenges that require a human touch. By shifting the emphasis from execution to ideation, AI has the potential to elevate the profession and unlock new levels of creativity and innovation. The role of education in preparing the workforce for these changes cannot be overstated. As traditional coding skills become less relevant, educational institutions must adapt their curricula to emphasize problem-solving, critical thinking, and interdisciplinary knowledge. These skills will be essential for navigating a world where AI is deeply integrated into every aspect of work. By equipping students with the tools to thrive in this environment, education can play a pivotal role in shaping a more inclusive and dynamic job market. Despite the challenges, there are reasons to be optimistic about the future of work in an AI-driven world. History has shown that technological advancements, while disruptive, often lead to the creation of new industries and opportunities. The transition from agricultural to industrial economies, for example, was accompanied by fears of widespread unemployment. Yet over time, these changes gave rise to entirely new sectors, from manufacturing to services, creating jobs that were previously unimaginable. Similarly, the integration of AI into the workforce has the potential to spur innovation and drive economic growth. The ethical considerations surrounding AI in the workforce are equally important. Ensuring that these systems are used responsibly and transparently is critical for building trust and minimizing potential harm. For instance, the use of AI in hiring processes has raised concerns about bias and fairness. Addressing these issues requires collaboration among engineers, policymakers, and industry leaders to develop guidelines and best practices for AI implementation. By prioritizing ethical considerations, The industry can ensure that AI is a force for good, enhancing rather than undermining human potential. The potential for AI to disrupt the job market also highlights the importance of collaboration between humans and machines. Rather than viewing AI as a replacement for human workers, it can be seen as a tool that augments their capabilities. By working together, humans and AI can achieve outcomes that neither could accomplish alone. This partnership has the potential to redefine what it means to work, creating a more dynamic and fulfilling experience for individuals and organizations alike. As the job market continues to evolve, the ability to adapt to change will be a defining characteristic of success. Engineers who embrace AI as a partner rather than a threat are likely to find themselves at the forefront of the industry, driving innovation and shaping the future of work. By focusing on collaboration, creativity, and ethical responsibility, the industry can navigate these changes in a way that benefits everyone. The integration of AI into the workforce is not a story of replacement, but of transformation. It challenges us to rethink traditional notions of work and to explore new possibilities for creativity and collaboration. By embracing this change with curiosity and resilience, we can shape a future that is not only technologically advanced, but also inclusive and equitable. The journey may be complex, but the potential rewards are immense, offering a vision of work that is more innovative, fulfilling, and sustainable. Societal and ethical considerations. The intersection of artificial intelligence and societal ethics is one of the most significant challenges of our time. As AI becomes increasingly sophisticated, its role in our lives deepens, touching nearly every facet of human activity. From healthcare to finance, education to entertainment, and most prominently, software engineering, AI's influence is reshaping the foundations of modern society. Along with this technological advancement come profound ethical considerations that must be addressed to ensure the benefits of AI are maximized while its risks are mitigated. One of the most pressing concerns is the transparency of AI systems. As these technologies grow more complex, understanding their decision-making processes becomes increasingly difficult. In software engineering, AI systems are already being used to write, optimize, and debug code, but their inner workings are often opaque. This lack of clarity can lead to significant issues when AI-generated code introduces vulnerabilities or biases. Ensuring transparency in AI systems is not merely a technical challenge. It is a moral imperative. Users, developers, and organizations must have the tools and frameworks to understand how AI arrives at its conclusions, fostering trust and accountability in its deployment. The issue of bias in AI systems is another critical area of concern. These systems are trained on vast datasets that often reflect the biases of their human creators or the societies from which the data is drawn. In the context of software engineering, biased algorithms can lead to the development of systems that inadvertently disadvantage certain groups or propagate harmful stereotypes. Addressing this issue requires a concerted effort to identify and mitigate biases at every stage of AI development, from data collection and model training to implementation and evaluation. By prioritizing fairness and inclusivity, developers can create AI systems that reflect a broader spectrum of human values and experiences. The potential for AI to be used deceptively is a growing ethical challenge. As AI becomes more adept at mimicking human behavior, the line between human and machine interactions is increasingly blurred. In software engineering, this could manifest in the creation of systems designed to exploit user behavior or manipulate public opinion. The ability of AI to generate convincing deepfakes or spread misinformation at scale poses a direct threat to democratic institutions and societal trust. Combating these risks requires robust safeguards, ethical guidelines, and regulatory frameworks to ensure that AI is used responsibly and for the benefit of all. The question of accountability in AI-driven processes is particularly complex. When AI systems operate autonomously, determining responsibility for their actions becomes a nuanced issue. In software engineering, if an AI-generated codebase leads to a system failure or security breach, who bears the responsibility? Is it the developer who implemented the AI, the organization that deployed it, or the AI system itself? These questions highlight the need for clear accountability structures that delineate roles and responsibilities at every stage of AI deployment. Without such frameworks, the risks of misuse and harm increase significantly. The ethical dilemmas posed by AI extend to its impact on the workforce. As AI systems replace or augment human roles, the social and economic consequences of this transition must be carefully managed. While AI can enhance productivity and drive innovation, it can also lead to job displacement and economic inequality. Ensuring that the benefits of AI are distributed equitably requires proactive measures, such as investing in education and reskilling programs to prepare workers for new opportunities. By fostering a culture of adaptability and lifelong learning, society can navigate the challenges of AI integration while minimizing its potential for harm. The alignment problem in AI is another crucial issue that has garnered significant attention. This refers to the challenge of ensuring that AI systems act in ways that align with human values and intentions. As AI becomes more powerful, its ability to pursue objectives autonomously raises concerns about unintended consequences. In software engineering, this could mean AI systems optimizing for goals that inadvertently conflict with broader organizational or societal values. Addressing the alignment problem requires interdisciplinary collaboration among engineers, ethicists, policymakers, and other stakeholders to establish shared goals and principles for AI development. One of the most promising aspects of AI is its potential to enhance human creativity and problem-solving capabilities. By automating routine tasks, AI frees up time and resources for individuals to focus on innovative and meaningful work. In software engineering, this means that developers can devote more attention to designing user-centered systems, exploring new technologies, and addressing complex challenges. However, realizing this potential requires a commitment to ethical practices that prioritize the well-being and empowerment of individuals over short-term profits or efficiency gains. The societal implications of AI extend beyond its immediate applications to broader questions about the role of technology in shaping human culture and identity. As AI systems become more integrated into daily life, they influence how we interact, communicate, and perceive the world around us. This influence is particularly evident in the digital spaces, where AI-generated content increasingly shapes the narratives we consume. Ensuring that these systems promote diversity, inclusion, and cultural sensitivity is essential for fostering a more equitable and connected global society. AI's rapid advancement also raises existential questions about the nature of intelligence and what it means to be human. The ability of AI systems to learn, adapt, and even create challenges traditional notions of creativity and agency. In software engineering, the prospect of AI systems independently designing and optimizing their algorithms blurs the boundaries between human and machine intelligence. Engaging with these questions requires a thoughtful and open-minded approach that embraces the complexities of AI while acknowledging its limitations and potential risks. The integration of AI into society is not a journey without risks, but it is one filled with opportunity. By addressing the ethical considerations surrounding AI, we have the chance to shape a future where technology serves as a force for good, enhancing human potential and fostering innovation. The decisions made today will have lasting consequences, influencing not only the trajectory of AI development, but also the values and priorities of the societies that embrace it. The path forward requires a collective effort to navigate the challenges and opportunities of AI with care, responsibility, and vision. By prioritizing transparency, fairness, and accountability, we can build a foundation for AI systems that reflect the best of human ingenuity and compassion. The integration of AI into software engineering and society at large represents a transformative moment in history, offering the potential to redefine what is possible while reaffirming our commitment to ethical principles and shared humanity. Conclusions: artificial intelligence is transforming the way we understand work, creativity, and progress, marking a pivotal moment in technological evolution. The advancements discussed, From AI acting as mid-level engineers to its implications for society and ethics, underscore a future brimming with both challenges and opportunities. This is not just a story of automation, but of transformation, where human ingenuity and technological power converge to shape a new paradigm. The shift in software engineering, where AI takes on roles traditionally reserved for human expertise, reflects a broader trend toward redefining how we work and innovate. As AI systems grow more capable, they free us from repetitive tasks, allowing us to focus on creativity, problem-solving, and the exploration of untapped possibilities. This transition brings a promise of enhanced productivity and collaboration, but it also demands responsibility, addressing ethical dilemmas. Ensuring fairness and fostering inclusivity will be critical to harnessing AI's full potential without leaving anyone behind. As we navigate this evolving landscape, the call to action is clear. We must embrace the opportunities AI presents while actively addressing its risks. By fostering adaptability, prioritizing ethical practices, and celebrating human creativity, we can ensure a future where AI becomes a powerful ally in building a better, more equitable world. The journey ahead is both exciting and uncertain, but it holds the promise of a profound reimagining of what it means to work, create, and thrive in a world increasingly shaped by artificial intelligence.